Hello, we are the Innovative Global Solutions Enterprise, and we are designing a low-cost modular infant incubator for use within developing countries. My name is Maggie Blevins. I am joined today by Morgan Thomas, our other team lead, as well as Graham Spalding, Noemi Heydrich, Ben Stallard, and Sydney Monger. I will begin our presentation with our purpose. Noemi and Sydney will then talk about our design. Then Morgan will talk about our humidity system. Next, Ben will cover our temperature system, and then we'll hear from Morgan again for vitals monitoring. Then Graham will talk about our control system. And finally, I'll wrap things up with our acknowledgements. In 2019, approximately 2.4 million children died within the first month of life. The highest risk areas of infant mortality are in sub-Saharan Africa, where it is 10 times more likely for an infant to die in the first month than in comparison to a high-income country. Figure 1 shows where the highest neonatal mortality rates occur. Low birth weight is one of the top 5 leading causes of infant mortality. In Africa, 1 in 10 infants are born with low birth weight, and one way to combat this is to provide the infant with a controlled environment. Our solution to this issue is to create a low-cost incubator with modular systems to increase efficiency and longevity of the device. Next up is Noemi with our design.
Thanks, Maggie. So the current design for our second prototype is shown in the CAD model on the left-hand side. We made a few design improvements from our previous prototype that we will discuss as features of this design. With that being said, these features include using plywood as our primary building material to save costs, adding large acrylic windows to maximize visibility of the infant, adding fans at the top of both of these smaller sidewalls, adding a separate drawer below the incubation chamber for storing tools and extra parts, adding a designated space for a modular controls panel, and lastly, we 3D printed a frame for an acrylic door that will slide horizontally to allow for accessibility for the infant, as well as reduce disturbances to the incubator's internal environment. And this door frame and the other 3D printed components can be seen on the CAD model image depicted in teal. And up next, Sydney will tell you more about our second prototype.
Thank you, Noemi. To continue on the design of the prototype, we chose to implement a breathable infant sleeping mat. This provides a soft surface while also mitigating suffocation risk for the baby. We also added handles for easy transport of the incubator. For future improvements, we want to change the main material of the incubator, add a locking mechanism to the door so it does not slide open on its own, and we would also like to look into improving and redesigning the door mechanism or adding additional doors to the incubator. Up next is Morgan talking about humidity controls.
Thanks, Sydney. Adequate humidity is necessary for an infant's skin to properly develop. Therefore, a humidifier was deemed necessary to implement into our incubator. The humidifier went under both steady state and transient testing to ensure accuracy and appropriate humidity could be maintained within the incubator. Next up is Ben with temperature control.
Thanks, Morgan. The components of the temperature control system can be seen here on the slide. To the left is highlighted in red, the portion of the control panel that is responsible for regulating the temperature of the system. And on the top right are the heating element, as well as the fan that blows the heated air into the incubator environment. And on the bottom is the temperature sensor we use to gain readings about what's going on inside the incubator. We performed a couple of tests to make sure that the temperature system was meeting our requirements. In this transient test, you can see that we reach marginal stability for our required temperature at about 3.5 minutes. And have a pretty small oscillation of 0.4 degrees Celsius. And in this test, you can also see that throughout the entire length of the test, aside from when we first turned it on, the temperature of the incubator stayed within the required bounds and didn't even get particularly close to exceeding them. Next up will be Morgan Thomas with vitals.
Thanks, Ben. So the vitals monitoring system will assist healthcare and infant caretakers in determining the status of the infant. For vitals, keeping the cost low without losing the necessary accuracy of data collected to help determine the health of the infant was the biggest goal. To help drive costs down, we used a reusable silicone band and is implemented along with the sliding buckle and snap buttons. These components can easily be taken apart for easy sterilization and will have minimal irritation to the infant due to silicone's chemically inert properties and ability to lay naturally flat to the infant's skin, reducing any unnecessary tightness of the band around the foot. This band will help hold the MAX 3102 sensor in place on top of the infant's foot where the dorsalis pedis artery is located, which will help track infant's heart rate and external body temperature. A market-grade thermometer was used, and the Innovo heart rate device was used for comparative studies to help determine the accuracy of the MAX 3102 sensor of the heart rate and external body temperature. An industry thermometer was used to determine the accuracy of the sensor, and in about approximately 10 seconds, the sensor was giving similar results to the industry-grade thermometer. The heart rate data was collected by both the Innovo and the MAX 3102 sensor, and with this study, it showed that less than 1% difference of the numbers from the sensor implemented in the incubator compared to the industry-grade sensor. Next, you'll hear from Graham about our controls and user interface system.
The control system is responsible for integrating all submodules into a complete system. That means monitoring the infant's vitals, regulating the temperature and humidity, and displaying this information to the user. The system is split into two separate modules, a main control module shown on the left, and a user interface module shown on the right. These submodules facilitate user interaction by simply plugging into a module interface, eliminating the need of electrical knowledge from the user. Their incompatible sizes also makes it impossible to put a module into the wrong slot. The user interface submodule, shown on the right, is used to convey and receive information from the user. The low power display shows the infant's vitals as well as the incubator's temperature and humidity. The push buttons allow the user to adjust temperature and humidity set points. The alarm alerts the user with a light and a buzzer. The screen also displays those issues. For example, it could be low heart rate, or refill the humidifier soon. Up next is Maggie with the acknowledgements.
Thanks, Graham. The team would like to thank our sponsors, General Motors, specifically Jason, Blake, and Zach for all their help and support. We would also like to thank Mary Raber in the Pavlis Honors College and Nathan, Lindsay, Eric, Brian, Carl, and Graceland with Plexus for their continued guidance. Finally, we'd like to thank our advisors, Dr. Tawari and Dr. Manzer, with special thanks to Dr. Rao for consulting with us on the biomedical aspects of the project. Thank you for watching.